What's hidden 6,371 km beneath your feet? The depths of our planet remain one of the most fascinating and terrifying mysteries in modern science. While humanity points its telescopes toward distant galaxies and searches for signs of life among the stars, the real abyss lies directly beneath our feet. Right now, as you watch this video, you are standing on a thin layer of rock, floating above a world of crushing pressure, molten metal, and temperatures capable of melting almost any material known to science. If Earth were sliced open like a giant machine, we would discover that everything humans have ever known exists on an incredibly fragile outer shell. On the scale of the entire planet, the crust is about as thin as the shell of an egg, and beneath that shell begins a descent into a realm no human has ever reached. Our journey starts only a few inches below the surface. At a depth of about 30 centimeters, the soil is already a hidden world. Insects build colonies, worms tunnel through the earth, and small mammals create underground chambers where temperature and humidity remain far more stable than above ground. For countless species, this shallow layer is an entire universe. But as we go deeper, the underground begins to preserve something else: history itself. Around 4 meters below the surface, archaeologists uncovered one of the greatest discoveries ever made: the tomb of Tutankhamun. Buried beneath dry Egyptian soil for more than 3,000 years, the tomb remained astonishingly intact. Gold, furniture, chariots, and even delicate fabrics survived because the underground environment protected them from oxygen and moisture. The earth had become a vault for human civilization, and that is one of the first great secrets of the underground. The deeper you go, the slower time seems to move. A few meters down, ancient history sleeps undisturbed. A few dozen meters down, another kind of world appears. Beneath cities and mountains, humans have carved enormous tunnel networks for transportation, mining, and military purposes. Some of the most complex underground systems ever built were created during times of war. The Kuchi tunnel networks, stretching for more than 150 kilometers, became hidden pathways beneath the landscape. During the Cold War, entire bunkers were constructed deep underground, designed to survive explosions that could destroy cities on the surface. Governments understood that the deeper you build, the harder you are to find, and the harder you are to destroy. But humans are not the only engineers of the underground. The animal kingdom has its own record holders. Nile crocodiles, for example, can dig burrows up to 12 meters deep. These tunnels provide protection from extreme heat and drought, creating some of the deepest natural dwellings made by any reptile on Earth. 12 meters may not sound very deep, but it is already equivalent to a 4-story building buried underground. And yet, compared with what comes next, it is almost nothing. The real challenges begin beyond the 1-kilometer mark. At these depths, the Earth starts fighting back. The pressure increases dramatically. The air becomes hotter. Ventilation becomes a matter of survival. One of the most extreme workplaces on the planet is the Mponeng gold mine in South Africa. The mine descends nearly 4,000 meters underground. Without powerful cooling systems, the temperature of the surrounding rock can reach about 66 degrees Celsius, hot enough to be life-threatening within minutes. Imagine working nearly 4 kilometers below the surface, surrounded by rock that feels like the inside of an oven. And even this is still only the outer skin of the planet. To understand how little we have penetrated Earth, consider the deepest hole ever drilled by humans, the Kola Superdeep Borehole in Russia. After decades of drilling, scientists reached a depth of 12,262 meters, more than 12 kilometers. It was an extraordinary engineering achievement, but compared with Earth's radius of 6,371 kilometers, it was barely a scratch on the surface. If Earth were the size of a basketball, the Kola borehole would be thinner than a human hair. And at that depth, something unexpected happened. The deeper the drill went, the stranger the rocks became. Temperatures rose far higher than scientists had predicted. The rock was no longer behaving like a rigid solid. Under immense heat and pressure, it began to flow slowly, almost like thick tar. Metal tools softened. Drilling became increasingly difficult. The laws of physics had not changed, but the conditions were so extreme that familiar materials behaved in unfamiliar ways. Then came one of the most surprising discoveries of all. Scientists found microscopic life deep inside the rocks, in places where no sunlight had ever reached, and where the pressure was hundreds of times greater than at the surface. Before this discovery, many researchers believed life could not exist so far underground. They were wrong. Earth was hiding entire ecosystems beneath our feet. And this raises a disturbing question. If life can survive kilometers underground on Earth, could similar organisms exist beneath the surface of Mars or the icy moons of Jupiter and Saturn? The deeper we explore our own planet, the more we change our understanding of life in the universe. But now, we are about to leave the zone of human exploration entirely. Beyond the deepest mine, beyond the deepest drill hole, lies a region that no machine has ever entered. The Mantle, a colossal ocean of heated rock that extends for nearly 2,900 kilometers and contains most of Earth's mass. Here, temperatures climb into the thousands of degrees, and the rock moves in slow currents that can take millions of years to complete a single cycle. Those invisible currents are powerful enough to move continents. North America, Europe, Africa, and Asia are all riding on pieces of crust that drift across the mantle like enormous rafts. Every earthquake, every mountain range, and every volcanic eruption is connected to the slow movement of this hidden layer. The ground beneath your feet is not fixed. It is floating on a restless ocean of rock. And far below that ocean, even deeper than any volcano has ever reached, something even more extraordinary is waiting. A churning sea of molten iron. The outer core, a metallic engine hotter than almost anything on Earth, generating the magnetic field that protects our atmosphere from the radiation of space. And at the exact center of the planet, 6,371 kilometers beneath your feet, lies a solid sphere of iron with temperatures reaching nearly 6,000 degrees Celsius. A hidden world under pressures more than 3.5 million times greater than the air around you. Now, we'll descend into that molten iron ocean and uncover the mysterious heart of our planet, the place that may hold the key to Earth's magnetic field, its geological activity, and perhaps the future of life itself. As we leave the mantle behind, we arrive at one of the most dramatic boundaries inside our planet. Nearly 2,900 kilometers beneath the surface, the solid rock suddenly disappears. In its place lies an ocean unlike anything found on Earth. Not water, not magma, but an immense sea of molten iron and nickel stretching for more than 200 kilometers in every direction. This is the outer core. If it were somehow exposed to the surface, it would instantly vaporize almost everything around it. Temperatures here range between 4,000 and nearly 500 degrees Celsius, comparable to the surface of the sun. Yet despite this unimaginable heat, the outer core is not simply a pool of liquid metal. It is in constant motion. Gigantic currents of molten iron rise and sink, driven by heat escaping from the center of the Earth. At the same time, our planet's rotation twists these currents into enormous spirals. Together, these movements create one of the most powerful natural generators in the universe. Earth's magnetic field. Although invisible, this magnetic shield surrounds the entire planet, extending tens of thousands of kilometers into space. Every second, the sun releases a stream of highly energetic charged particles known as the solar wind. Without protection, These particles would gradually strip away Earth's atmosphere and expose the surface to dangerous radiation. Mars provides a warning of what can happen. Scientists believe the red planet once possessed a magnetic field similar to Earth's. But as its interior cooled, that magnetic shield weakened and eventually disappeared. Over billions of years, the solar wind slowly eroded much of the Martian atmosphere, leaving behind the cold, dry world we see today. Earth escaped that fate because deep beneath our feet, the outer core never stopped moving. Every compass pointing north, every aurora dancing across polar skies, every satellite orbiting safely above the atmosphere, all owe their existence to this hidden ocean of liquid iron. Yet the journey is still not over. At a depth of about 5,150 kilometers, we reach another astonishing boundary. Here, something that seems impossible takes place. The liquid metal becomes solid. Welcome to Earth's inner core. At first glance, this makes no sense. How can iron remain solid at temperatures approaching 6,000 degrees Celsius? The answer lies in pressure. The weight of the entire planet presses inward from every direction with unimaginable force. At the very center of Earth, the pressure exceeds 3.5 million times the atmospheric pressure at sea level. Under these conditions, iron atoms are compressed so tightly together that they cannot move freely despite the intense heat. Instead of melting, the metal remains solid. The inner core forms a gigantic sphere, roughly 2,440 kilometers in diameter, slightly smaller than Earth's moon. For decades, scientists believed this enormous iron sphere simply sat motionless at the center of the planet. But recent discoveries suggest a far more fascinating reality. By studying thousands of earthquakes from around the world, researchers noticed tiny changes in the speed of seismic waves traveling through the inner core. The differences were incredibly small, often measured in fractions of a second. Yet over many years, those tiny variations revealed something extraordinary. The inner core may rotate at a slightly different speed than the rest of the Earth. Some studies suggest it once rotated slightly faster than the surface. Others indicate that its movement has slowed or even shifted relative to the mantle. Scientists continue to debate exactly how this hidden sphere moves. But one thing has become clear. The center of our planet is not frozen. It is still evolving. Even more surprising is the possibility that the inner core contains another hidden layer. Some seismic studies indicate the existence of an innermost inner core, a smaller region with iron crystals arranged differently from the surrounding material. If confirmed, it would mean that Earth's center has its own internal structure, almost like discovering another planet hidden inside our planet. No one has ever seen this mysterious region. Everything we know comes from seismic waves generated by earthquakes. These waves travel through Earth much like medical ultrasound passes through the human body. As they encounter different materials, they change speed, bend, or reflect. By analyzing these changes, scientists can reconstruct a remarkably detailed picture of the planet's interior without ever physically reaching it. Every major earthquake becomes another opportunity to study Earth's hidden heart. Every new dataset helps improve our understanding of a place that no human will ever visit. But the core does much more than generate Earth's magnetic field. It also powers the geological activity that shapes the surface. Heat from the inner core slowly flows outward into the liquid outer core and then into the mantle. Those rising currents inside the mantle drive the movement of tectonic plates. That movement creates mountain ranges, opens new oceans, closes ancient seas, triggers earthquakes, and feeds volcanoes that can reshape entire landscapes. Without the energy stored deep inside the Earth, our planet would gradually become geologically inactive. Volcanoes would disappear. Continents would stop drifting. The magnetic field could weaken. Over immense spans of time, Earth might begin to resemble the silent landscapes of Mars. Fortunately, that hidden engine has been running continuously for more than 4.5 billion years. But despite centuries of research, scientists still face enormous mysteries. Exactly what elements are mixed with the iron in the core? How fast is the inner core truly rotating? Why does its motion appear to change over time? When did the inner core first begin to solidify? No single experiment can answer these questions. The pressures are simply too extreme. The temperatures are too high, and the distance is too great. Everything we know has been pieced together from indirect evidence, advanced computer models, and laboratory experiments that recreate only tiny fractions of the conditions found at Earth's center. Yet with every passing decade, new discoveries continue to reshape our understanding. The deepest place on our planet remains one of the least explored regions in existence. And perhaps the most remarkable fact is this: the greatest mystery on Earth is not hidden across the ocean, or buried beneath an ancient ruin. It is directly beneath every step you take. Now, we'll explore whether humanity could ever reach Earth's center, why drilling deeper may be impossible, and the incredible technology scientists are developing to unlock the secrets of the world beneath our feet. For thousands of years, people have imagined what might exist at the center of the Earth. Ancient civilizations believed the underworld lay beneath the ground. Later, writers imagined vast underground oceans, lost civilizations, and hidden worlds filled with giant creatures. In the 19th century, Jules Verne inspired millions with Journey to the Center of the Earth, suggesting that an incredible world might exist beneath the planet's surface. Today, science has replaced myth with evidence. And the truth is even more astonishing. The greatest obstacle to reaching Earth's center is not distance. It is survival. The deepest point ever reached by humans remains the Kola Superdeep Borehole in northwestern Russia. After more than 20 years of drilling, scientists finally reached a depth of 12,262 meters. It was one of the greatest engineering achievements in history. Yet compared to the full distance to Earth's center, it was almost nothing. If Earth were the size of a globe sitting in a classroom, the deepest hole ever drilled would barely scratch the paint on its surface. Everything beneath that point remains completely untouched. So why can't we simply keep drilling? The answer begins with heat. As engineers drilled deeper into the Kola borehole, temperatures increased much faster than expected. Instead of the predicted 100 degrees Celsius, the rocks reached nearly 180 degrees. At those temperatures, drilling equipment began to fail. The surrounding rock no longer behaved like a hard solid. Under enormous pressure and heat, it slowly deformed like warm plastic, squeezing against the drill and making further progress almost impossible. Every additional meter became more difficult than the last. Even if engineers had continued, far greater challenges awaited below. Thousands of kilometers deeper, temperatures rise to nearly 6,000 degrees Celsius. No metal ever created by humans could survive for long under such conditions. Pressure presents an even greater problem. At the center of Earth, every square centimeter experiences a force equivalent to the weight of hundreds of elephants pressing down on it. Steel would collapse. Titanium would deform. Even the strongest modern materials would fail. There is currently no machine capable of surviving those conditions, let alone drilling through them. That is why scientists have adopted a completely different approach. Instead of sending people into Earth's interior, they allow Earth itself to reveal its secrets. Every year, thousands of earthquakes shake different parts of the world. Most are too small for people to notice. But each one sends seismic waves racing through the entire planet. These waves travel at different speeds depending on the material they pass through. Some pass easily through solid rock. Others disappear when they encounter liquid metal. By recording these waves with thousands of seismic stations across the globe, Scientists can create detailed images of Earth's hidden interior. It is remarkably similar to a CT scan performed in a hospital. Doctors never need to open the human body to see what lies inside. Likewise, geophysicists can study Earth's interior without ever traveling there. Modern technology has made these images more detailed than ever before. Powerful supercomputers analyze millions of seismic recordings collected over decades. They reconstruct the hidden structure of the mantle, outer core, and inner core with extraordinary precision. Meanwhile, laboratory experiments attempt to recreate the conditions found thousands of kilometers underground. Scientists place microscopic samples of iron between two flawless diamonds. As the diamonds squeeze the metal with enormous force, powerful lasers heat it to thousands of degrees. These experiments last only moments, but they allow researchers to observe how materials behave under conditions similar to those near Earth's center. Combined with computer simulations, they provide some of the strongest evidence for the structure of our planet. Even so, many mysteries remain unsolved. One of the biggest questions concerns the future of Earth's core. The inner core slowly grows as liquid iron from the outer core cools and solidifies. The process is incredibly slow. Over 1 million years, the inner core grows only by a tiny amount. Yet over billions of years, those tiny changes reshape the planet from within. Eventually, however, Earth's interior will cool. Scientists estimate that this process will take billions of years. As the planet loses heat, movement within the outer core will gradually weaken. The magnetic field may eventually disappear. Without that invisible shield, Earth would become increasingly vulnerable to the solar wind. Fortunately, this future lies so far away that the sun itself will likely transform into a red giant long before Earth's core completely cools. Long before that happens, our planet will face an entirely different fate. Yet even today, Earth's magnetic field is constantly changing. The magnetic North Pole slowly drifts across the Arctic. Throughout geological history, the magnetic poles have reversed hundreds of times. North became south. South became north. Scientists still do not fully understand why these reversals occur. The answer almost certainly lies within the turbulent motion of molten iron hidden deep inside the outer core. Perhaps the most humbling realization is this: humanity has landed on the moon, sent robotic explorers to Mars, flown spacecraft beyond the edge of our solar system, and built telescopes capable of observing galaxies billions of light years away. Yet we have never traveled more than a tiny fraction of the distance toward the center of our own planet. The greatest unexplored frontier is not always above us. Sometimes it lies directly beneath our feet. Every mountain, every ocean, every city, every forest rests upon a thin shell floating above an enormous hidden world of moving rock, molten metal, and a blazing iron heart that has remained active for more than 4.5 billion years. That invisible engine drives the continents, powers volcanoes, creates earthquakes, generates the magnetic shield that protects every living creature on Earth. Without it, our planet would be lifeless. So the next time you stand on solid ground, remember this: beneath your feet lies a journey of 6,371 kilometers into one of the most extreme environments in the known universe. A place hotter than the surface of the sun. A place where pressure defies imagination. A place no human has ever seen. And perhaps the greatest mystery is not what we've already discovered, but how much of our own planet is still waiting to be uncovered.